All right, ladies and gentlemen, so we're going to look at number 12 because a lot of you had trouble with number 12, and I'll tell you why. It's very normal, and the reason why I say that is because this is a definition question. It's really testing your knowledge of a definition, and the definition that we are testing is remainder theorem with respect to divisibility. So right away in the question, as you read the question, you'll notice it starts off with, first of all, stating some of the obvious things that we notice. So yes, in the polynomial p of x, guess what, ladies and gentlemen? This is p of x. And they're telling you p of x is all of this craziness, whatever it is, right? It's defined above, and they tell you that k, the letter k, is a constant. And here's your k. Okay, big deal. If p of x, and this is where it gets important, or it is important, if p of x is divisible, again, divisibility rules, by x, so right away you should be thinking this polynomial is divisible by this x value. Well, that means that x is a factor, and therefore, as a result, we would look at p of x as equal to 0 in the sense of x is 0. So what that means is, so let me give you the short version of the explanation first, is that if I substitute p of 0, this is equal to 3, parentheses 0 squared, plus 10 times 0, plus 5, minus 5, times 0 minus k. And when you solve this, you get 0 is equal to 15 plus 5k. And if we solve for k, we find that k is equal to negative 3, which would have been your answer choice A. Now, if you notice, I have remainder theorem written up here, and I have that on purpose. So let me show you an example. If you're cool with this definition and you understand this at this point, you don't need to continue with me. You just watch the rest of the explanation. So let's say I have 3 factors. Let's say I have x plus 1, x plus 2, and x minus 3. And I go ahead and I devise my polynomial equation from it. So first thing I'll do is I'll factor these two. So I get x squared plus 3x plus 2. Remember, it's first. X times x is x squared. Inner 1x, 2x. So 1x and 2x is 3x. And 1 times 2 is 2. All right. And all of that now gets multiplied times x minus 3. So if I distribute that x to all 3 terms, I get x cubed plus 3x squared plus 2x. And I'll do the same thing with the negative 3. Distribute it to all 3 terms, so I end up with negative 3x squared minus 9x minus 6. Okay, I group that together. I get x cubed. This all cancels. Minus 7x minus 6. And that's my polynomial function, in a sense, in theory, a p of x, right? My polynomial function, which is x cubed minus 7x minus 6. Now, I'm going to use synthetic division to show you using one of these factors, and then I'm going to use another factor out of as an example. So if I use synthetic division, let's say I use the x minus 3. So that means that x minus 3 equal to 0 means that x is equal to 3. Okay, so that means that in synthetic division, I would put my 3, and now my coefficients 1, 0, negative 7, negative 6. If you're wondering why 0, remember, we're missing an exponent value here of x squared. So I have to add, in theory, what I'm doing is I'm saying this is x cubed plus 0x squared minus 7x minus 6. That's why the 0 is there. Okay? Right, so using synthetic division, look at what happens. I drop the 1. 3 times 1 is 3. 0 plus 3 is 3. 3 times 3 is 9. 9 minus 7 is 2. 3 times 2 is positive 6. If you notice, this is 0. So it is okay to say that my p of x is divisible by x minus 3, which means it's divisible by the x of x minus 3 as a factor, and therefore I have no remainder. My remainder is 0. All right. If I were to say I have p of 0 in this case, then this would be 0 cubed minus 7 times 0 minus 6, and so the rule would be that the p of 0 in this case would equal negative 6. And that is the thought here. In our thought here, this is p of 0, where up here p of 0 should be negative 3. So when we look at these examples, when we substitute in a value, so remember I said to you, this is one of the factors. Let's use a factor that is not part of the equation. So let's use something like x minus 5, where you have x minus 5 equal to 0, which means that x is equal to positive 5. Well, if that is the case then, and I were to use the 5 instead, and I did 5, and I had my 1, 0, negative 7, negative 6, you would drop the 1. 5 times 1 is 5. 0 plus 5 is 5. 5 times 5 is 25. Negative 7 and 25 is going to give you positive 18. And 5 times 18, that's going to give you, I'm not saying anything. It's early in the morning. Give me a break. So 18, let's see here. 18 times 5. I want to say 90, but 18 times 5. Yeah, 90. Okay. So this is 90, and then 90 minus 6. Well, that's going to give me 84. Okay. I have a remainder. In this case of 84. Remember, the last column is always a remainder column. Well, if that's the case, then that means that if I did 5 cubed minus 7 times 5 minus 6. Remember, 5 cubed is 125 minus 35 minus 6. Okay, well, use your math knowledge. So 125 minus 35, which gives you 90, minus 6 puts us back at 84. And that is the thought, that whatever you substituted into a polynomial function for that x, that is the actual value that results in this column. That's what that question is testing you on, believe it or not. So again, the key is understanding that statement right there, where p of x is equal to or is divisible by x. And if that is the case, then that means that x is equal to 0. When x is 0, what results in this part of the remainder? Okay? All right, hope that helps.